It will happen in this cube because 11th will also be writing. So you have to prove that whenever f is an increasing function, g of x will also be an increasing function.
If f is increasing, that implies that f dash x is greater than 0.
This is not a completely composite function.
If any time f of x is increasing, then f dash x has to be greater than 0, right?
Yeah.
So if we just differentiate that thing,
Right.
all the f dashes of x are always positive.
Okay.
So we'll be left with only the
Now what if the f of x there is negative?
Okay, no, this f of x is only one f of x will be.
Don't think that f dash x is positive means f of x is also positive. F of x can be negative there also. Done, Singha. Done? Alright, can we discuss now? So for the next few months, please do not try to skip classes because important chapters will be not taken up. This itself, after this in fact, Maxima, Minima is another important chapter. Then we will be starting with integration, indefinite, definite, differential equations, vectors, 3D. Those are very heavy chapters, very heavy chapters. You miss here and there and it's gone. And then we will have probability and all those chapters which are lighter. Probability, matrices, determinants, they are lighter ones. Alright, so let's differentiate this first. G dash x. Let's apply chain rule here. So 3f of x whole square into f dash x. Here I will have 6f of x f dash x. Here I will have 4f dash x plus 5 plus 3 cos x minus 4 sin x. Okay. Now at least from these terms, can I take f dash x common? Correct? And I will have 3f of x whole square minus 6f of x plus 4 plus 5 plus 3 cos x minus 4 sin x. Okay. Now can I write this as 3 times f of x minus 1 the whole square plus 1? Yes or no? Can I simplify this term as 3 times f of x minus 1 whole square plus 1? Correct? Now, do you see that this term will always be positive? Correct? Do you also realize that this term will also be positive? The reason being 3 cos x minus 4 sin x can have a minimum value of minus 5. and 5 is already there to take care of that minus 5. Correct? So it can be positive or minimum 0 it can be. Okay. Now the only thing that is doubtful is f dash x. So if your f dash x is positive, that means when your f of x is increasing function, won't it make everything positive? So your g dash x would be positive whenever f dash x is positive, which implies g of x is increasing whenever f of x is increasing. Is that okay? Fine. Now we'll move on to another concept of monotonicity, inequalities using monotonicity. Is that okay? Should I clear it? So next concept is inequalities using monotonicity. Okay. I'll first start with a very easy example to understand. Okay. Let's say I ask this question. Which is the greatest among 1, 2 to the power half, 3 to the power 1 by 3, 4 to the power 1 by 4, 5 to the power 1 by 5, 6 to the power 1 by 6 and 7 to the power 1 by 7. Okay. Question is, which of these has the greatest value? And don't try to use calculator now.
2 to the power 1 by 2.
Something is wrong with the mind.
Is it 1?
How can it be 1? 2 to the power half is 1.4. So which is the greatest among these values? You can treat this one as 1 to the power 1 by 1, just for the sake of making a pattern. Can you formulate a function looking at the pattern? X to the power 1 by x. Okay, so let's have a function like x to the power 1 by x. Okay. Now if I ask you, when is this function increasing, when is this function decreasing? Assuming that your x is always positive. Okay, what will you say? You will differentiate this, put it greater than 0 and try to the differentiation of x to the power 1 by x, let's take log, in fact ln, okay, and differentiate with respect to x. So 1 by y dy by dx will be equal to 1 by x square minus ln by x square, correct? Send the y to the other side, that means x to the power 1 by x, and we'll try to solve this inequality when is this greater than 0. Okay. Now if you see this clearly, you would realize that the only term which is negative over here, or maybe negative, or maybe deciding the sign, is this 1 minus ln x. This is always positive. This is always positive. So when 1 minus ln x is greater than 0, your function would be increasing. That means when ln x is less than 1, your function will be increasing. That means when your x is less than e, your function would be increasing. Correct? So when you start with 0, means 0 to e, the function is increasing, and e onwards the function is decreasing. Correct? No? Correct? That means e is somewhere here, 2.718 to the power 1 by 2.718. Correct? So your function is increasing till it reaches 2.718. That means of all these values over here, 2.718, which is e to the power of 1 by e, would be the greatest. Correct? Now, your function is on the rise like this, and then after e, the function decreases. No, it keeps on decreasing after that.
So isn't 4 to the power 1 by 4 same thing as 2 to the power 1 by 2?
Hold on, we'll come to that. Now, if the function is increasing before e, which one will have higher value? This one or this one? 2 to the power 1 by 2. So on the left side of e, this fellow will have more value. Correct? Now the function is decreasing after e. So which one will have more value? 3 to the power 1 by 3 or 4 to the power 1 by 4? This will be the winner on the right side. Correct? Now on the left side, 2 to the power 1 by 2 is the winner. On the right side, 3 to the power 1 by 3 is winner. Now who is the winner among both the winners? That I have to find out. Okay, now see. Somebody just now pointed out this is same as this. Correct? And you know this is more than this. Hence this has to be more than this also. Yes or no? 2 to the power 1 by 2 is same as 4 to the power 1 by 4. And just now we figured out the function is decreasing after this. Means this will be higher than this, this will be higher than this, this will be higher than this, this will be higher than this. That means this is higher than this, which in turn make this higher than this also. Hence who is the winner in this entire event? 3 to the power 1 by 3 will have higher value than any of these terms.
So I don't understand. So I lost you after that 2 to the power
Okay.
2.7.
Let's say the increase is like this. Here is 1 to the power 1. Okay. Then there is 2 to the power 1 by 2. And then somewhere comes e to the power 1 by e. And this is at the top. This is the highest of all the values. You understand why e to the power 1 by e is the highest of all the values?
Yeah, because you get that.
Because the function is increasing till e and then falling down from there. So e is at the saddle point, at the top point. Correct? So e to the power 1 by e would be the maximum of all such values. After that the function becomes 3 to the power 1 by 3, 4 to the power 1 by 4, 5 to the power 1 by 5, 6 to the power 1 by 6, 7. So it is on the fall. It is going decreasing as you increase the value of x. Okay? Now here, how do I know 2 to the power 1 by 2 is more or 3 to the power 1 by 3 is more? Because they are on the opposite sides of e. So they are both on the rising part.
Yeah.
Right? So it is now known that this will have the same value, right? 2 to the power 1 by 2 and 4 to the power 1 by 4 will have the same value. Because both are equal to 2 to the power 2. Yes, 2 to the power half. How? 4 you can write as 2 square. So 2 square to the power 1 by 4 is 2 to the power 1 by 2. So this and this have the same value, and you know this is higher than this. That means this will be higher than this also. Hence the maximum value that will be there for these series will be of 3 to the power 1 by 3. So at a place where you least expected calculus to be applied, it has been applied. Okay. A twin question of this is, which is more or which is greater? E to the power pi or pi to the power e?
Pi to the power e.
How?
Because that's 3.14 to the power 2.7 and the other one is...
So there the base is high, power is less, but e to the power pi will have a higher power than and lesser base.
2 by 5 and 5.
How do you trade off between?
So one is like down 2 to the power.
One has a lower base but a higher power, other has a higher base but a lower power.
Yeah, so e to the power pi is about, let's say, 2 to the power.
That about you cannot say because they are all irrational numbers. E to the power pi is about? What is the expected value? Huh? No, let him tell. E to the power pi is about?
E to the power pi will be approximately 27 to the power 27, approximately. Little less than that.
You'll come to know what is the value. It is less than that. Don't worry.
Less than 27.
Less than 27 is also very high value. Okay. What about pi to the power? She is calculating. No, use a calculator. Without use of calculator, you have to say which one is greater, e to the power pi or pi to the power 8. They are very close in fact, yeah. Answer is e to the power pi. How?
So it's e to the power pi.
E to the power pi is greater. E to the power pi is somewhat about 23.4.
24.7.
And pi to the power e will be 22.4. Yes.
I totally don't suppose to. No, but there should be some substantial reason.
Okay. Now, to decide which one is greater, can I say if I take the same power on both of them, will the inequality sign change?
Yeah.
Will the inequality sign change? It will not change. Okay. That means I have to decide which one is more, e to the power 1 by is more or pi to the power 1 by pi is more. Okay. Now we just not decided by taking the function x to the power 1 by x that the function is increasing from 0 to e and decreasing from e to pi. Correct? That clearly says the value of e to the power 1 by e would be more than pi to the power 1 by pi because pi comes after e and the function is decreasing. So the lesser the value of x, the higher will be the value of the
You also know that 3 raised to 1 by 3 is greatest and 3.1 comes after that. And since e also.
Okay. So in this case, if I take the opposite route, that means if I take the power of pi on both the sides, means e to the power pi would be greater than pi to the power e. Okay. I'm not doing the entire thing once again because I've already taken the function x to the power 1 by x and showed you when it is increasing, when it is decreasing. Next. Prove that. Prove that ln 1 plus x is less than x for positive values of x. In fact, now graphically you can show very easily, but let's say if I have to do this using calculus. So many questions based on inequalities of functions are framed on the concept of monotonicity. Prove that ln 1 plus x is less than x for x greater than 0.
So you just
So we
differentiate
get 1 by 1 plus x is less than for all x because 1 plus anything will be greater than.
Who told you that this inequality will be existing? That is, f of x is there, then g of x is derivative also will be there.
If you move x to that side and then differentiate this,
That doesn't tell you. The function is this, that doesn't mean it's derivative. I will give you an example. Function is below the x-axis, but still can be exist. Guys, one very important concept brought out during this discussion. If f of x is negative, that doesn't mean f dash x will also be negative. For x is a domain.
We can prove it whether it's increasing continuously or not, right? And after we do that, we know that x is like a constant function.
I'll get you.
So, like we can find if like ln of x actually say that it's a constant increasing or in this case,
Yes, constant increasing in this case. Yes.
x is like a constant value. It doesn't change the thing. Only that I can.
But a line and a curve, both are increasing. But still this can be below this. Getting the point? If something is like this and something is like this, for both the case the derivative is positive. But still this function is below this function. Yes.
It's like f of x is equal to ln 1 plus x minus x.
Right.
So it will be continuous. And will it be
It's a differential case.
and it will be increasing. If it is increasing, then we directly got it.
When x is greater than 0, this will be less than 1, so it will be increasing. You are very close to the answer. You are not able to find a proper way to present your case.
If it's sticky,
Sir, we just can agent can be a part of the proof. Like it need not be the proof but a part of the proof.
What is that?
Sir, like I can take a random value. It can be very small, so I can prove that ln 1 plus that value is always less. It is less than that value. So since f dash x is greater than g dash x, this will keep going ahead and this will not be able to catch up with that function.
The gap between the function is increasing, you're saying.
I've proved that f dash x is greater than g dash x. And I can
Now, when you see the gap between the function is increasing function, there can be a case when if it is not increasing also and still this function is higher than the other one.
yeah.
Then still that function will be greater than the other one. So what you're doing, you're taking the difference of the function to be a function and you're showing that it's always increasing. Correct? Yes or no? That is the case where definitely. But what if the function is decreasing also but the gap is such that this function is always above the other one?
so basically, if it's given that condition, x is greater than 0, if we just substitute it here for all x greater than 0, this thing will be decreasing.
Right, so what he said was fine, that's why I did not counter his example. But there can be an instance where you cannot say that, yes. So in this case, yes, you are safe. So let's take this example. So let's take a function which is ln 1 plus x minus x. Okay? Correct? Find the derivative of this function. 1 by 1 plus x minus 1, which is minus x by 1 plus x. Can I say when x is positive, this will always be a negative term? Correct? Means f dash x is a decreasing function. Correct? Means f of x is a decreasing function, yes or no? That means if function is a decreasing function, its value at 0 plus would be higher than the value of the function at any x greater than 0 plus. Correct? No? It is a decreasing function. F dash x less than 0 means f of x is a decreasing function. Correct? So it is falling down. If it is falling down, that means its value at the initial point would be the highest. Yes sir? The value at 0 plus would be higher than any value of the function at any point greater than 0. So f dash 0 plus would be greater than f of x. Okay. Why 0 plus I have taken? Because 0 doesn't fall in the domain. So 0 plus I have taken. What is f dash? What is f of 0 plus 0 only? So can I say 0 is greater than f of x, and f of x is nothing but ln 1 plus x minus x. Okay. Send the x on the other side, that means x is greater than ln 1 plus x for any x greater than 0. Yes or no? And hence it proves this inequality. Getting the point? So how things are getting related to my calculus. And JEE Advanced, I am telling you, they bombard questions based on monotonicity. And many students are not able to realize that boss, calculus is also going to be used here. Take a break. On the other side of the break, we'll talk about Maxima and Minima.
So since you don't have too much time, can you just start off with the word process for Maxima?